In our laboratories today, we live in an atmosphere dim with the flying fragments of exploding atoms. And on this occasion, I wish to say a few words on the methods and ideas employed to break up atoms and to realize, if even on a small scale, the old dream of the alchemists of transmutation of one element into another. This is a problem in which I have been personally engaged during the greater part of my scientific life, and during this time I have witnessed an astonishing increase of our knowledge. At the close of the 19th century, the labors of the chemist had resolved the matter of our material world into 80 or more distinct elements, and the atoms of these elements appeared to be permanent and indestructible by the forces then at our command. A great change in our ideas resulted from the discovery of the electron and of the spontaneous radioactivity observed in the heavy elements, uranium and thorium. Soddy and I were able to show in 1903 that radioactivity was a sign and measure of the instability of atoms, and that the atoms of uranium and thorium were undergoing a series of spontaneous transformations, giving rise to 30 or more new radioactive elements. These elements were ephemeral and broke up according to a definite law, and either a massive alpha particle or a light beta particle was hurled out during the explosion of an atom. It soon became clear that this property of radioactivity was confined to only a few elements, while the great majority of the ordinary elements seemed to be permanently stable over periods of time measured by geological epochs. The next problem was to examine whether means could be found to break up the stable elements by artificial methods. Before this could be attempted with any chance of success, it was necessary to have a clearer conception of the structure of atoms. The idea of the nuclear structure of atoms, which I suggested in 1911, has proved very useful for this purpose. It became clear that to effect a veritable transformation of an atom, it was necessary to change the charge or mass of a nucleus, or both together. Now, the minute nuclei of atoms are held together by powerful forces, and to effect their disintegration, it seemed likely that a very concentrated source of energy must be applied to the individual atom. The bombardment of the nuclei by the energetic alpha particles from radium appeared to be the most promising method for such a purpose. Acting on these views, I found in 1919 that nitrogen nuclei could be transformed by bombarding them with swift alpha particles. Hydrogen nuclei, or protons as we now term them, being ejected with high speed as a result of the transformation. Later, we were able to show that a number of light elements could be transformed in a similar way. Progress in our knowledge of the mechanism of these transformations became more rapid when powerful electric methods were developed to count automatically the swift particles ejected during these nuclear explosions. It became clear that to extend our knowledge, a more copious supply of bombarding particles of different kinds was necessary. Charged atoms of various sorts can be produced in vast numbers by the electric discharge through gases, and then accelerated by the use of high voltages. In this way, we have been able to obtain for our experiments in transmutation intense beams of protons and alpha particles, while the discovery of heavy hydrogen has given us a new projectile of remarkable efficiency in transmuting atoms. By these and other new methods, we are able to break up atoms in a great variety of ways and produce a number of new elements, or rather isotopes of known elements not observed before. Some of these are found to be unstable and break up according to a definite law like a radioactive element. The discovery in these experiments of neutrons, uncharged atoms of mass 1, has proved of great significance and importance, and has given us a much clearer understanding of the actual structure of nuclei. This new field of work is now attracting much attention throughout the scientific world, and the progress of our knowledge is very rapid. We are witnessing today the rise of a new department of fundamental knowledge, nuclear chemistry, which is concerned with reactions and changes which may be brought about in the minute world of the atomic nucleus.